Hi everyone! After you finished your method test prep, you should be watching this video. I'm going to apologize in advance if you hear some banging in the background. I'm recording it in our room and there is construction above us, so please don't pay any attention to that. But if you need to, pause the video, rewatch it, rewind it, do whatever you need to do just to go through and get your notes for today. So we're talking about multiple angles and power reducing formulas, and you should be able to rewrite angles so that we can write them in terms of unit circle values that we know and use our power reducing formulas to evaluate. And that's our whole goal today. Those are what we want to accomplish, and we should be able to use our multiple angles going forward. And these should look familiar to you. Mr. Carlson talked about these last year with you, or you should have seen these in your regular Algebra 2 class. So we can use the sum and difference formulas for identities to help solve for double angle formulas. And double angle literally just means taking twice the angle. So if I have 2 times theta, remember theta is part of that angle. You can't take that away from it. It goes with it. So I can rewrite that as the sine of theta plus theta, because that's what 2 theta is. It's multiplication is the shortcut for addition. So I can rewrite that and now use my sum and difference formulas to write it as the sine of theta plus the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. Well, lucky for us that I can rewrite that again using the commutative or associative property. So we can rewrite it as the sine of theta, cosine theta, sine of theta, and cosine theta. And if these were not colored, you wouldn't be able to distinguish between the two of them. So if I have sine of theta, cosine theta, plus sine of theta, cosine theta, well, I have 2 of them. And that's our shortcut. If I have the sine of 2 theta, all I have to do is rewrite that as the 2 times the sine of theta and cosine theta. We also have a formula for the double angle of a cosine, and we are again using the sum and difference to prove it. So we're going to rewrite cosine of 2 theta as the cosine of theta plus theta, substituting that in for this. And we're going to use that sum and difference formula. Remember, cosine is the opposite. So it's cosine of the first, cosine of the second, minus sine of the first times the sine of the second. And since our thetas are indistinguishable, they both are talking about that same angle, we can rewrite that. Cosine times cosine is cosine squared, sine times sine is sine squared. And this right here is enough. You can have the cosine of 2 theta is the cosine squared of theta minus sine squared of theta. And that is great, but if I don't have that information for both of those and I don't want to find it, I can do one of 2 things, and I can simplify that formula, it's kind of like the big dog of the cosine double angle, into 2 options by replacing for either cosine squared of theta or replacing for sine squared of theta, because those stem from the big dog formulas. So I can replace cosine squared with 1 minus sine squared, and then I have 1 minus sine squared, so it's 1 minus 2 sine squared theta. And likewise, I can also sub in for sine squared of theta if I want. So I have cosine theta minus 1 minus cosine squared theta, which means I have to distribute my negative. And I get cosine squared theta minus 1 plus cosine squared theta. Collect your cosine squareds, and it's 2 cosine squared theta minus 1. So in fact, we have 3 different formulas that we can have for our double cosine angles. So there's 1, here's 2, and here's 3. And these are not ones you have to memorize. You do need to know how to work with them, but you need to know how to derive them. So if you choose not to memorize it, you need to know how to use the sum and difference formulas to get your double angle, and the sum and difference formula to use your sine of 2 theta. This is an expectation that you know these or are able to derive them. Your choice. Know them or derive them. So there they are again. And here's your double angle formula for tangent. 2 times the tangent of our angle divided by 1 minus tangent squared of u. And then again, you've got those three options for your cosine, which we can all just interplace values that are on our big dog formula. And remember, keep in mind that when we write cosine squared of u, that means the quantity of the cosine of u is being squared. That means cosine of u times cosine of u. Okay? So let's put that into place. Whoop. Silly me. We are going to take a look at the first one. And we've got 2 times the cosine of x and then plus sine of 2x. So we've got two different angles here. Here's our first angle, angle 1, and here's our second angle. This is angle 2. And in fact, angle 2 is just double angle 1. So we can use that to our advantage, and we can reduce that and plug in one of our equations for the sine of 2 theta, or 2x, by putting in 2 sine x cosine x, because that's the formula for the double angle of sine. Now we're all talking about the same angle x. And we've got it set equal to 0, so that means we're going to try and solve. We want to factor out a GCF, because that's our first rule of factoring. So take out a cosine of x, and we can take out a 2 cosine x, so we're left with 1 plus the sine of x equals 0. Zero product property rule says we have to set them each equal to 0, so 2 cosine x equals 0, and 1 plus the sine of x also equals 0. We want to isolate for that trig function, so get cosine x by itself, and get sine of x by itself. And then we want to isolate for the variable, and we're going to do that by taking the inverse trig function. So x equals the cosine inverse of 0, and x equals the sine inverse of 1. Remember, we're asking for what angle gives us those values. So if we take a look at the cosine function, here's one sketched of period of cosine. We've got 2 values where that happens. That happens at pi halves and 3 pi halves, and it's going to keep on happening every value after that and every value before that. So we're going to add pi n or n pi or nk, whatever your choice is. Then we're going to take a look at our sine value, and we're looking where our sine function is -1. And that's down here at 3 pi halves. And that doesn't happen again for another full period. And remember, the period for sine is 2 pi. So x equals 3 pi halves plus 2 pi n. All right, here's our next question. It says if sine of theta is 3/4 and theta has its terminal side in the first quadrant, which is good for us because that means all trig functions are positive, it's asking us to find the exact value for each of the following. So what I want you to do is pause the computer and give it a shot. Alright, so taking a look at letter A, we've got 3 options for the cosine of 2 theta, and I want to pick the one that's easiest for me with my given information. And for me, that's using the sine function. So I'm going to use the 1 minus 2 sine squared theta. So I'm going to plug that in, and then I'm going to substitute. I know what the sine of theta is, that's 3/4, so I'm going to plug that in, follow my orders of operation, so square it, then multiply by 2, and then I'm going to subtract. So 8/8 minus 9/8 is -1/8. Then when I'm going to go to tangent of 2 theta, I need to find cosine, or I need to find my missing side length because tangent is opposite over adjacent. So I'm going to use my triangle, build it in the first quadrant, because that's where it said to draw it. Opposite over hypotenuse is 3/4, so that means the 16 squared is 9 plus something, and that something is the square root of 7. I'm going to write down my formula and plug in my values. So the tangent is 3 over the square root of 7. I'm going to take my tangent and also place it in the denominator. I'm going to square it. I have to rationalize my 1 in the numerator. So simplifying that, we've got 6 square root of 7 over 7. And 7 sevenths minus 9 sevenths is negative 2 sevenths. So copy, change, and flip. And simplify. So I get negative 3 times the square root of 7. And hopefully that's what you got. This next one is the sine of 4 theta. And that's theta plus theta plus theta plus theta. Or 2 times 2 theta. So I'm going to use my double angle formula for sine. This time using 2 theta as my angle. And that looks like this. 2 times the sine of 2 theta times the cosine of 2 theta. And then we're going to simplify even further. But lucky for me, I already know one of them. I know that the cosine of 2 theta is negative 1/8 because I did that in part A. So I'm going to substitute that in. And I can replace the sine of 2 theta with my formula, 2 sine theta cosine theta. And I'm going to plug in those values and simplify. And here's our answer, negative 3 square root of 7 over 32. And then last but not least, these are your power reducing formulas. So please take a minute, pause the video, and copy these down. All right, and here's that last problem. It says rewrite sine to the 4th power of x as the sum of first powers of the cosine of multiple angles. So that means we want no exponents on our trig functions. So I can rewrite this, which is the sine of x to the 4th power, but I want to use those power reducing formulas, so I want to write it as a power of 2. So we're going to write sine squared of x squared, and we're going to replace sine squared of x with that power reducing formula, which is 1 minus the cosine of 2x over 2 squared. So we're going to do that. We're going to double it, multiply it by itself. So 1 minus the cosine of 2x over 2. And what I'm going to do is I'm going to pull out this fraction. This is 1/2 times 1/2, which is 1/4. And what I've got left on the inside would be 1 minus cosine of 2x and 1 minus cosine of 2x. And if we FOIL that, first times first, outside's negative cosine of 2x, inside's negative cosine of 2x, so negative 2 cosine of 2x, and last times last. Negative times a negative is a positive, and we've got the cosine squared of 2x. Now it said first powers, so this is a problem right here. We want to get that to be a power of 1, so we're going to simplify that again. So we've got 1/4 times the quantity of 1 minus 2 cosine of 2x plus 1 minus, or 1 plus the cosine, and it was double the angle, so double 2x is 4x over 2. We're going to simplify and clean this up. So I'm going to get that fractional part distributed and see how much I can clean that up. So I've got 1/4 minus 2 times the 4th times the cosine of 2x. And I've got plus 1/4 times, I'm going to split this up, 1/2 and 1/4 times the cosine of 4x over 2. So we've got 1/4 plus 1/8, which is 3/8. And we've got negative 1/2 of the cosine of 2x. And then we've got a positive 1/8 times the cosine of 4x. And you can leave it like this, or if you want to be super fancy, you can pull out that 1/8 And so that I get 3. If I pull the